Hello, students. We are looking at 12.2. We now have some tools from 12.1. We know that triangles are congruent, and I don't have to get all of the information. I only need some pieces of information. But we do know side, 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 and side, angle, side are enough to prove that the two triangles have to be congruent. Now, a triangle can be constructed as well with different pieces of information. Now, as a very brief reminder, we also talked about one other one, and I'm probably said it before. I'll say it again. If you have two sides like this, and you know their lengths, and then you know an angle, but the angle is not between the two sides, we can't say side, angle, side. This would be either a side and a side, then an angle, if you kind of read it counterclockwise. If you read it clockwise, it would be an angle, then a side, then a side. And just remember, I know I've said it before, but if you are using a bad word, then you're using bad math. So ASS is not going to guarantee that you get two triangles that are the same, right? You may not get two triangles that are the same. They might be different triangles if you try to use this property. Okay. So that is something to be aware of. But now we're going to take a look at the next one. The next one they list is angle, side, and angle. And I want you to kind of think about this, though. An angle, a side, and an angle. If anyone ever told you two angles for a triangle, you should be able to find the third angle, right? So that would be this one's 40, this one's 60. Well, 40 plus 60 is 100. You know how big the remaining angle is. So anytime you see an angle and an angle given, you automatically get the other angle for free. But as it turns out, because you have these two angles kind of going up, they're going up at a particular rate, they will intersect at the same point. It's almost like we're going back to lines with slope. The slope over here, the slope over here, you're like, they're coming up. It's going to have to be exactly the same. All right, so let's take a look. Angle, side, angle. And in case you're wondering, the two properties they ask you to learn about in this chapter are angle, side, angle, and angle, angle, side. But remember, if I give you an angle and an angle, and I don't tell you the third one, you can know the third one by knowing they have to add up to 180 degrees. So you can find that last piece. So if I tell you a side, like this side, and then I give you any two angles, and this is a fun fact, any two angles. I could give you the two angles that are on opposite sides. That would form angle, side, angle. If I tell you that, then because this length is fixed, the angles will go up in such a way that that point will be unique. But what if I didn't tell you that? What if I gave you an angle here and an angle up top? Well, just remember, if I know two angles, guess what? I know the third angle. So I guarantee you I can find this other angle, and we're right back to angle, side, angle. So if angle, side, angle works, then angle, angle, side has to work as well because they're basically the same. Okay. So this is a theorem. Remember, a theorem is something we should be able to prove, and that would be something that we need to do. And lastly, angle, angle, side is another theorem we should be able to prove. Again, these are all contingent on knowing some things about triangles, right? So the things that we learned in section 1, those still apply. And so if you know the three sides are the same, then the triangles are congruent. All right. So basically, if you know two angles and any side, the triangles are going to be congruent, okay, if they match up with the corresponding pieces. Now, the sides, as we already noticed, were kind of strange. And yeah, so we'll leave it at that. I know there are some students who say, can we know less? But I want you to notice, if you look at all of the possible options, So notice we could have all the sides that we know. We could have two sides and an angle, two sides and an angle, two sides and an angle. Likewise, we could also have, I just tell you all three of the angles. I tell you two angles with a side and something like this. All right, so let's take just a brief moment. If you have, because it's a triangle, right? If you have side angle, that's the same thing as angle side side. So those are the same. And we've already said if you do have anything like that, we have to rule it out because that is bad word and therefore bad math. But it's also bad because it just means you won't create a congruent triangle. You might create two triangles. Okay, so that one's out. Let's look over here. That means angle, angle, side is the same as side, angle, angle. These are identical. And once you know two angles, you know the third. So it's actually basically the same as this one right here. So all of those work fine. Okay. So any of these, I know two angles and a side, those work to find a congruent triangle. Side, angle, side, and side, side, side also work for finding a congruent triangle. And the only other piece up here is all the angles. If you know all the angles, there's no guarantee you know the two triangles are the same. They could be like bigger. Remember that photocopier example. And so they would be called similar, but they would not work for congruence. So for congruence, we actually have four different pieces we could use. You could think of five if you think of SAA, ASA, AAS. But really, I try to group all these together, at least in my mind. That way I'm not trying to think about too many other things. But right here, those are all the same because if I know two angles, I know the third angle. Over here, I don't know any angles, and it's rare. It's rare that you can get by with that, but you can do it once. After that, you need to know two of the sides, and you have to know the angle between them. All right, let's see what else do we have in this section. So we do have some theorems about a parallelogram. I'm going to save this one because I think it ties in nicely with one of the next components on the next page. Actually, 2 pages from now. So this is them showing an example with a full proof. And you'll notice that they do talk about things that say these segments appear in triangles that seem to be congruent, but you have to prove the triangles are congruent. Here they do it by angle, side, angle, and then you get the corresponding parts being congruent. Okay. All right. So the reason I skipped that last theorem is there's actually a page, and everything on this page is basically a theorem you can prove. So if you know the definition of a trapezoid, you should be able to prove that consecutive angles between parallel sides are supplementary. To me, this one's a pretty quick proof because if you know that the parallel sides are here and here, and I'm asking to show is this angle plus the angle below, do those add up to 180 degrees? We've already done that in chapter 11. That was on our way to proving the sum of the triangles angles is 180 degrees. Okay. So just realize this right here is a list of proofs. I could say, take this shape, it's a parallelogram. Prove that opposite angles have to be congruent. That would be angle B and angle C. Prove to me those have to be congruent. Why do those have to be congruent? Prove that opposite sides are congruent. Prove that the diagonals bisect each other. That means they cut each other in half. It does not mean that they're the same length. Okay, down here, notice you will see some beautiful pieces like a rectangle, which by definition it's a parallelogram with right angle, which means it has all the properties of a parallelogram. So for a rectangle, opposite sides are congruent. Opposite angles are congruent. All of those are still true. And lastly, you get a few more on the next page about a kite, a rhombus, and a square. Now remember, a rhombus is a very special shape because by definition, two adjacent sides are congruent. It's a parallelogram with that, which means by definition, it also meets the definition of a kite. So a rhombus has all the properties of a parallelogram and a kite. This makes the rhombus probably the best shape when you're doing constructions. And I'm not even kidding. Why? The diagonals of a rhombus are going to be perpendicular to each other and they're going to bisect each other, which means we can build a rhombus and then create the diagonals and they're going to be perpendicular bisectors. Okay. All right, so those are all the theorems. What does that mean? Every piece of this could be a test question, and that's where I tend to pull my proofs on the test from. So if you wanted a list, here's the list. You can go through and practice them if you want, but they're all very, very similar. If I want to prove the diagonals of a rectangle are congruent, then I have to create these congruent triangles. Again, my overall goal is to prove that the diagonals from BD and AC, I need to prove those are congruent. Okay. So that's what I want to show. I usually skip down a little bit. Like I'll put what I want to show maybe right there, but then I'll skip down and say, okay, here's my actual proof. I'd say, okay, Scott, a rectangle is a parallelogram. Got it. So that means those are parallel and these are parallel. Got it. Okay. And what do I know? I know it is a right angle. It has to have a right angle. It's a parallelogram with one right angle. And if it has a right angle and they're parallel, think about all the other stuff you get for free. Then a corresponding angle has to be congruent, which means this is 90 degrees. And vice versa, going over here, this corresponding angle has to match, which means this one's 90 degrees, and vice versa. And we basically say a rectangle has all 90-degree angles, right? Then, and this is where I'm going to give you a tip. And the reason why I came and did this example 7 is the tip is there will be times where it will be easier for you if you draw two versions of the picture, right? Here's BAD, and right above it, I draw the other portion, which would be ADC. Okay. And the reason that I'm going to do that is I want to label the pieces. I want to be able to say, here's a right angle, there's a right angle. Opposite sides are congruent. That's one of the properties of that parallelogram, which means opposite sides, BA is opposite to CD. Okay. And then maybe you'd even say, well, wait a minute, Scott, isn't this shape down here the exact same as this shape right there? Because it is AD. And I'd say yes. So while they gave you the picture right here where everything's on top of it, like I just find that that's really hard for me to see. So I'm going to recommend try this. If there's too much going on in the picture and you kind of know what you want to do, because we're trying to prove the diagonal, which is AC, has to be congruent to BD. So split it into two pictures. Maybe then you can see why the triangles are congruent by side angle side and then you can make your claim about the corresponding parts. So again, that's my push in the right direction as you're doing homework and you're doing other components. Yeah, I think that's it. They do talk, I mean, there's a new term here called a median. A median does cut something in half, but what it does is it connects a vertex to the midpoint that's opposite to that one. Okay. And really all they're showing you here is they're saying prove the median contains the vertex of a right triangle that is half the length of the hypotenuse. Okay, well, if ABC is a right triangle and CD is a median, prove the median contains that vertex of a right triangle and that it has to be half the length of the hypotenuse. So what you're doing is you're saying that this median contains the vertex of a right triangle. So your goal is to show that CD to AB that we get this 2-to-1 ratio here, so that AB would be twice as big as CD. And we can do that by kind of creating a shape. We have the 90-degree angle up here, and we can kind of build this, the two triangles here that we get when you put kind of the identical shape. Notice this, the two angles here from CD, we just kind of extend that down over here to CD, and we build this shape. That shape now has, look at it, we're going to have congruent triangles, which means certain pieces are going to be the same. Once I do this, let me label this a little bit more so we can kind of see what we got going on. Take a look. What I have is I have angle B over here, which is this one, and it's going to match up with the angle on the other side. I have the 90-degree, which matches up. And then I'm going to have this angle A over here has to match up with this one over there. It has opposite angles. So I now have a quadrilateral with opposite angles being congruent. All right. Not to mention the fact that the side lengths would be the same if I had done this. So again, by side, angle, side. So I get a lot of these free pieces. And because of that, I can actually say that this shape is a parallelogram. And it's a parallelogram with a right angle, which makes it a rectangle. And if it's a rectangle, well, the diagonals of a rectangle hit in the middle and they bisect each other. So that's, I mean, they're congruent, but they also bisect each other. And that's how you can make this conclusion that the median containing the vertex is half the length of the hypotenuse. Phew. Which is kind of a cool piece. It's also a, yeah, we'll see how that connects back to circles here in a little bit. Nope, let me delete the images off of here. Intersecting circles. I think the drawings at times can get a little bit like, what? But as you look at the pictures, try to be able to pause for a second. And if you need to, use your hand and cover up a part of the image right away. So if you want to, I would cover this part up first and just look at what's inside the first shape. Then go back and cover up the larger one for a moment until you can kind of see what's going on in the smaller shape. And that should be enough to get you where you need to go. All right. So we've talked about what makes triangles congruent. And there's 4 things: side, angle, side, 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 angle, angle, side, and side, angle, angle. Those are your 4. What's interesting is if we try to generalize then, what does it take for a quadrilateral to be congruent? So that's a 4-sided shape. And you might think, okay, what about side, 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 side? If we have the same sides, all the same sides, is that enough? And I think, well, it depends on who you are, but you might be able to see, wait a minute, but I could have a square with all the sides being the same, or I could have a rhombus with all the sides being the same. And a rhombus doesn't have to be a square. So they may not be the same shape. And that's correct. As it turns out, if you know all the sides, the only time that works is with triangles. After that, go for the other one, side, angle, side. Well, if you know side, angle, side, that's 2 sides and 1 angle, you're gonna need a little bit more. So what that means is I know this, and I know that, and I know this angle right there. In order to guarantee we have the same quadrilateral, just picture, perhaps the next one goes up here and then comes down. Okay, so there it is. That could be. In order for me to guarantee that I tell you the correct information, I'm going to need to get more information from you. If I knew this angle right here, then I have the direction. And if I knew this angle right here, I'd have the direction. So that would mean side, angle, side as a quadrilateral. You could tell me angle, side, angle, side, angle. Yes, that would be enough information. Or if you didn't give me that information, think about what else you could tell me. You have to fix things, kind of lock them down. So you could say, well, wait a minute, Scott, what if you know this side, you know this side, and you know that angle? If I tell you the lengths of the other 2 sides, right, because those points are fixed, once you know those lengths, you could kind of show, hey, let me swivel my swivel my compass and they'll see where those intersect. If that is it, you don't need the other angles. So you have two options. Angle, side, angle, side, angle, or side, angle, side, angle, side. So those are the pieces that will work with quadrilaterals. Okay, and that is true. That actually continues on up through not just quadrilaterals, the pattern would continue up through pentagons and more. And that wraps up our chapter. So in terms of constructions, I'm not sure we had a ton of constructions in this section. But let's see here. Do we need to draw anything? Side angle side congruence. No. Those are all proofs, not constructions. Those are all proofs, not constructions. Yeah, I think. Yeah, there's not anything else with constructions. They're all just the congruence pieces for this one. So when we get to 12.3, we'll do a little bit more with constructions. And that's where that rhombus really comes into play. But for right now, that's it. So we'll head on to 12.2. We'll go through the homework section and we'll take it from here. All right, off you go.